In order to determine if a set of points is a function, you need to look for one specific thing. No repeating x values with different y values. So we want something that's not a function. So that means we want a repeat. If you are not a function, it's because you have a repeating x value. No repeats here. No repeats there. Here's a repeat. So that makes this the answer. The next question says, which ones do represent a function? So that means no repeating x's. That fails. This fails. This fails. This one passes. So that means the answer is the last choice here. Next topic. Determine if a graph is a function. A graph is a function if it passes the vertical line test. That means whenever I draw vertical lines through the graph, I never have a repeating value. If I have a repeating x value, then it fails the vertical line test. So this graph here fails. It's not a function. Again, whatever graph you have, when you draw vertical lines, if you ever touch in more than one location, that means you fail the vertical line test. This is not a function. This one passes. None of my vertical lines touch that graph twice or more at the same time. This one is a function. Watch the animation here to help. See that vertical line? That's your pencil scanning the graph. The next topic is identifying linear functions from points. This question has 2 vocabulary words in it. These points need to be both linear and a function. Linear is very specific. It means you have a constant rate of change. So for this option A, my points are -8, -6, 0, and 2. My y values are -5, -4, -1, and 0. I'm looking to see how these numbers are changing. Going up 2, going up 6, going up 2. All right, now I'm not done because I have to check these y values. How are they changing? This one here is going up 1. This one here is going up 3. And this one here is going up 1. Oops. Now I need to look at these rates. Sorry, on that last one I wrote over it. The first one has a delta y of 1 and a delta x of 2. The second one has a delta y of 3 and a delta x of 6. They look different, but they're actually equal. And my third one has a delta y of 1 and a delta x of 2. So these are constantly the same fraction. That means that this is both linear and a function because it has no repeating x's. Now that's a tough one, but sometimes you have to draw the table to really see the pattern. So the answer here is A. Let's try another one. Which tables represent a linear function? All right, again, we're looking at the patterns here, right? And when we're done, we can create our delta y, delta x ratios and see if they are constant. So let's take a look here. Letter A, +1, +1, +2. Now over here, it's plus 3, plus 3, plus 6. So let's see. My first fraction is 3 over 1. My second fraction is 3 over 1. My third fraction is 6 over 2. Now, is it different, or is that also 3 over 1? It is. All of these are constantly the same rate. That makes A our answer. One more time. Let's take a look at this linear table here, or let's take a look at this table and see if it's linear. This one goes up 3. This one goes up 4. This one goes up 3. Okay? This one goes up 2, up 2, up 2. It's definitely not linear because 2 over 3 and 2 over 4 are not the same. So this one is out. Let's go over here. Plus 1, plus 1, plus 2. Plus 2, oh, whoops, sorry. Minus 2, minus 2, minus 3. All right, our fractions are 2 over 1, negative 2 over 1, and negative 3 over 2. They are not the same. These are both out. Now for this third one. Looks like I go up 4, up 4, up 3, up 6, up 6, up 3. Well, 6 over 4 and 3 over 3 are not the same fraction. That must mean this last one is correct, but let's check and be sure. Whoa, sorry. Plus 2, plus 3, plus 2, oops. Okay. Minus 2, minus 3, not minus, plus, plus 2, plus 3, plus 2. All right, 2 over 2, 3 over 3, 2 over 2. That's the winner. Let's take a look at the next section. How to tell if something is increasing and not straight, right? Increasing means as you read the graph, your eyes go up. See how my eyes are moving up? And then here, my eyes are moving down. So that means these are the two increasing sections. Section 1, section 2. Question is, which one is nonlinear? And that's this section here. So what we do is we draw a line from the start to the finish, and we look at those numbers. So between negative 9 and negative 5. Between negative 9 and negative 5. And then I go to the choices, and I find which choice says that. Between negative 9 and negative 5. One more time. We're looking for something that is both increasing and nonlinear. Well, this is increasing, but it's straight. This is also increasing, but it is not straight. That makes this the interval we're looking for. Scan up to find the starting and ending points, 5 and 9. So I scroll down and I look for 5 and 9. The next section is comparing rates from different representations. So the initial question asks for a rate of change that is less than this one. Well, this one is 5 over 4. 5 divided by 4 is also equal to 1.25. So we're looking for something with a slope that's lower than 1.25. Now this might be a little challenging for you since these will all be fractions. We have our two perfect corner points. 1, 2, 3, 4, 5 is our rise. 1, 2, 3, 4 is our run. So this one also has a slope of 5 over 4, which is not less than this one. So that makes this one out. I could also scan my other graph down here. This one has a slope of 1, 2 over 1. 2 over 1 is greater than 1.25, not less than. So that must mean one of my tables will be the solution. So let's take a look at this table here. Now you don't have to find all of the patterns, you just need to find the pattern of 2 points. Any 2 points you want. So maybe these two. This looks like it increases 4, 15. And this looks like it increases 3. Well, 15 over 3 is 5. So that's not less than 5 over 4. This one here increases 2 and increases 4. And 2 over 4 is 1/2, or 0.5. And that is less than 1.25. So D is our solution. Let's try this again with another question. The graph of a function is shown on this coordinate plane. Which relationship represents a function with a lower rate of change? Well, you have to find out what the rate of change is. So find 2 perfect corner points. Here I see a lot. It looks like it goes down 2 over 1, down 2 over 1. So I need something that is lower than -2. When I look at all of my options, I see that the first two, which are equations, I can very quickly find their rates of change. This one is equal, and this one is not lower. 5 is not lower than -2. So both of these are out. Let's take a look at these rates of change. This one looks like it's going down 16 and down 4. -16 over -4 is +4, which is not lower than -2. That's our target. So here it looks like we go down 7 and we go up 4. -7/4 is -1.75. So that means D is the right answer. The last section is writing a table, writing a linear equation from a table. Well, you need 2 numbers. You need the y-intercept, which is the number when x is 0. So far, we know that we're going to end with a -7. Now we have to find our slope. That's easy enough. Find the patterns using any 2 points you want. I'm going to use these 2 points. My y looks like it's going up 3, and my x looks like it's going up 1. So that means the rate of change is 3. My equation is 3x minus 7. I type it here in the box. One more time. My y-intercept can be found in the table by finding when x is 0. That means my b is -6. Now all I have to do is find my slope. I think I'm going to use these 2 points. My delta y is 6. My delta x is 1. 6x minus 6 is my equation. And that's how you complete assignment 301.